Hello everyone, welcome back to our Generative AI series. In our previous lecture, we understood why LangGraph was introduced and the limitation of traditional LangChain workflows. We learned that as AI applications become more intelligent, they need capabilities such as decision making, loops, retries, dynamic routing, human approvals, and long running workflows as well. That is exactly what LangGraph solves the problem. But understanding why LangGraph exists is only the first step. But to build real world AI agents, we need to understand the building blocks that make LangGraph work internally. So by the end of this lecture, we'll understand the key components of the LangGraph. So without any further delay, let's get started. So key components of the LangGraph. So every LangGraph application is built upon a few fundamental components. So each component have a specific responsibility. They'll perform some separate task. Okay, so when these components work together, they will form a intelligent AI application or AI workflow, which is capable of making decisions, calling tools, maintaining context, and interacting with humans whenever is required. So we have to make the humans also in the loop. So whenever AI is generating some wrong output, that human will interrupt in between and they'll come and they'll mention it, okay, this is the wrong, we have to do this in the another way, because our application is not supporting that part. Okay, so human intervention is needed here. So what are all these key components are? We have nodes, edges, state, cycle, HITL, tools, RAG, workflows, APIs, and LangSmith. One by one, we'll go and learn all these components. So we'll go with the nodes. So a node represents a single task inside the workflow. It means it will just do the only a single task. It will not go and perform some another things. Okay, so it will just perform the only one task inside the workflow, and the individual component or any agents, this will represent in the workflow. It means the process which automates the work. So this is a smaller part of that which is going to automate the work. So nodes can be act as an actor that interact with each other in a specific way. They'll have some functionalities, according to that they'll interact with others. And so each node here, it is representing a step. So for example, we are calling an LLM. This is a node and this is one step. Then we are going to retrieve the document. That is another step. So this is a one by one step, or we can say this is a single task which is we are representing in the form of nodes. Then calling an API, sending an email, like this, what are the task is there, they are represented as a node over here. So if we'll see for our resume application, we are uploading the resume. After that, we are extracting that text. After extracting that text, we have to retrieve the ATS rules. And when we'll have ATS rule, we'll call the Gemini model and it will generate the report for us. So this is the overall workflow for the nodes. So okay, so this is one node, this is another node. So this is a single task we are performing over here. So here each step is representing a single node concept. Then edges. It just connects all the nodes together. So with the help of edges, we are connecting here the nodes, and this will define what next node is here. Okay, we have to execute based on the current state. If we are connecting with the another another node, it will be defined with the help of the edges. So we know, okay, when we'll be completing the first node, we have to go to the fourth node, right? So with the help of edges, we are going to decide this, and they can follow the fixed path or branching condition, whatever we are implemented in our system. So according to our system, it will decide whether it will go for the fixed path or it will choose the branching conditions. Okay, so here LangGraph is supporting different types of edges. Okay, so we'll have normal edge, conditional edge, and loop edge. So if we'll see for normal edge, this is a fixed path. It will go from node A to node B. Then it will be coming to the conditional edge. Conditional edge means it will have some branches, like if we'll be using the if else block, that is again a conditional statement, right? So here this is also a condition. From retriever, it will decide whether it will have enough information. So it will go for it has enough information, it will go and generate the document. But if it will not have enough information, it will go for the search engine, it will do some another process, it will go to the DB and it will retrieve all the information, then it will go for the generation. But if we have enough information, directly we are going for the generation process. So this is the conditional age. According to the conditions, we are deciding whether we have to go for the enough information section or not enough information section. Okay, then at the end we have loop edge. This is the last one. It means we have one agent which is going to write or fix code, okay, and it will then run the test, and if any test failure will be there, it will go back, means it will be looping back to the same point, and again it will be writing and fixing that code, because we have some issues in the test files, right? So it will go and fix that test file. When it will be got fixed, then it will again go for the run test. It will be going in the write and fix code mode till the time that test is not getting fixed. So these are the three kinds of edges we have. Then graph architecture. We have two kinds of graph architecture. One is stateful graphs and another is cyclic graph. So we'll look into that one by one. So first we'll go with the stateful graphs. So stateful graph means each node. We already talked about node, right? So in each node in the graph, that will represent the step in computation and retain the information about the previous step. So here we already know that node is a nothing but it is a one step which we are going to perform here. So every node in the graph, it will have something to compute, or it will have to perform some operations, and whatever the output it will be getting it, that also we have to store it over here. Okay, so this is the this is going to retain that information. Then state. State means a state stores all the information generated during the workflow execution, because we have to pass that information to the another step. So we have to store that information. So we don't want to lose the information here. After every step, what we'll do is every node that can end now, it will have the current state data, because that process is done and it have the current state data. So next node, what it will do is it can go and read the current state, whatever the information is there, update it, and passing that information to the updated state to the next node. So it will also perform some operation and it will pass that information to the next node. Okay, this allows the workflow to remember the previous actions. So it will not go from initial step and it will run all the flow, and then it will go get to know that okay, what will be the output, but it has the previous information and it will just go and perform his own task, and after that whatever the output he is getting from that nodes, it will be sending to the another node. So this is a continuous processing, so it will have the full context with it, and this makes sure that the contextual and continuous processing of the information is going on. Okay, and this will be the throughout the workflow. So if we'll see here example, we'll have a user query and there is a few questions. These are the states. We'll be asking a question or history or retrieve docs or answers. Okay, so we'll have this information, and for this node A, it will update the state, it will have the update information. Then it will go to the node B. Node B, what it will do, it will just read the updated data. It is not going to modify it, it will not going to write it anything over there. So what node C will do, it will go and update that data. Okay, so here this is the step by step process. So we have one node which is performing one step, then node B is performing another step, node C is performing another step. So this is the stateful graph. So for example, in ChatGPT, we'll mention it, my name is Ankita. Then this name gets stored inside the state. So in this process, it will be stored like questions, history, retrieve, right? So this name will be stored inside the state now. If later we'll be going and asking back what is my name, which is already stored in the state, and it will give the answers correctly because it already have that information according to our requirement, right? We already mentioned it to that. And then without a state, every request would be treated as a brand new request. So here every request is a not a brand new, because we are storing that data before. Okay, then cyclic graph. A cyclic graph will contain at least one cycle, and that path will start and end in the same node. Wherever we are starting, we'll be coming back to the same point, and this is essential for the agents runtimes. So sometime we'll have some complex workflows which will involve the cyclic workflows, where outcome of the one step which will be taking from the another step. So it means from one step that is dependent on the another steps, because we are taking that output from the another steps, and this will allow the workflows to revisit to the previous node. Here we can go to the previous node as well, because this is a cyclic flow, we are making a cycle over here, and this is essential for the agentic AI development. Okay, because agents often need to repeat these tasks until the desired result is come, right? So just like as we talked about, if we are writing a code, we have to write the J unit for that. So till the time that J unit will not fix, it will go again in loop and loop, and it will fix it. When that will be done 100%, then it will be over. So that there is a cycle for writing the code. It will test it, it will write the again code, and it will go back and again do testing and writing the code, right? So that is a cyclic behavior we need it over here. So if we'll see, if we want to generate some answers, it will go and evaluate that answer. If that answer will be correct, it will go, it will be yes, then it will end. If that answer is not correct, just like we took the example of J unit, so if that answer is not correct, it will go and improve their prompt, and again it will write the code, and when it will generate the response again. So it will go in this loop again and again, again and again, right? It will be improving the prompt again and again. It is not just only a one time job. Okay, so again another example, if we are writing a coding agent which will write the Java code, so what it will do is it will execute the code. It, if any compilation will fail, it fixes the code and run it again, so it is again going to run that code. So this cycle continues until the program executes successfully. So in these cases we need a cyclic graph. Then monitoring mechanism. Monitoring mechanism means human in the loop. So here this means we have to make sure that all the agents or all the workflows, there will be some phase where human will always be in a loop. Okay, so at some point of time in the process before making the final decision, we need the human approval over here. So instead of allowing that AI models or tools to make every decision automatically, the workflow can pause and wait for a human approval or human feedback. When human will provide the feedback, maybe it will take 1 day or 2 day or half an hour or maybe 10 minutes as well. So it will wait till that time. So this is a collaborative process where AI can perform the computational capabilities or repetitive work, where a human can review the output or provide some judgment and make a critical decisions over here. So this will improve the reliability, because a human catches error or edge cases that AI might miss here. So instead of blindly trusting every AI decision, we can go to the human in the loop process. Okay, so user is requesting, we are giving some prompt. What it will do is AI will analyze that process. When analysis will be done, it will go for the human approval. When human will approve it, yeah, human will say yes, he is agree, then it means we'll get the response. If it will, human will not approve, it will go and modify and retry that thing. So whatever the user will provide according to that, or sorry, whatever human will provide according to that, it will go and modify that data and retry it. Okay, suppose for example, if we are building an AI resume screening app systems, so the AI analyzes 100 of resumes and it will recommend the best candidates for us. So however, before sending interview invitations, here the HR team review those recommendations before it will be going to the candidate. Before it will go and send to the invitation to the candidates, it's better that HR will take a review on this part, and they'll recommend which candidates you can go and send the mail. So only if HR approvals, it will go and continue the process. Tools. So sometimes the LLM itself cannot answer the questions. So in such cases, these agents will be using the external tools. These are the external functions or services that will help the agents to perform a task or get the information from the outside world. Okay, so for example, if we'll talk about what is today's weather in Delhi. So instead of guessing the agent, it will call the weather API and return the latest weather to us. So it don't need to assume anything over here. So if a user will ask a question, then assistant will go and it will ask for it's need a some tool. So when it will get the tool, so it will go for the weather API and it will check, okay, what is the weather condition today and what user want to get the answer from this one. Then it will again go for to the assistant and it will respond us back. So this is the flow where we need a tool to call the external APIs for getting the appropriate answers. Then RAG. So we already learned about the RAG concepts, but high level we'll see it over here. So RAG will combine the power of LLM with the contextual information from any external sources. So we'll have few relevant documents which are the input for the generation. So we'll store that concept. We'll augment that concepts, or we'll augment that document and we'll have it. Then LLMs can use that information with us. Okay. So for example, what is my company leave policy? So this common LLM or generic LLM, they are not aware about this part because that is a company specific flow. Okay, so here the workflow retrieves the leave policy which will be documented from the vector database and provide an accurate response to us. So we already have that data in our DB, we can fetch it, that data. So that is only the company specific part we are going to use it over here. We are not going to use the generic data for the company leave policy. So if user will ask any question, it will go for the embedding and that data will be going for the vector database, and from there it will match the relevant documents from there, and it will, or relevant chunks from the vector DB, and then it will retrieve that documents, and after that it will send that data to the LLM model, and then LLM models will responses according to these documents what data we shared, right? Then workflows. So a workflow, this will represent how these components or how different nodes will interact with each other. So we can arrange the node in a workflow and make it as a complex or dynamic workflow. So it depends how we are going to use that workflow. So unlike the LangChain, LangGraph workflow will include branching, loops, parallel execution, human approval, multiple agents will also be there. So this is completely different from the LangChain workflow. Okay, so if we'll see here, it will start a functionality, then it will go for the assistant, then assistant needs some tools, and then it will use the tool. Yes, it's needed a tool, it will go for the assistant, then it will call the LM models, and then it will be int. But here if it don't need any tools, then it will go for the LLM model. So here we are doing it a branching way. So we have two options, whether it will go for the yes or whether it will go for the no option. So we are giving some conditions which will be branching or looping that conditions. Okay, and here we can do the parallel execution as well. Then APIs. LangGraph already provides a set of APIs that will enable a user to interact with its components. So we do not need that components to write it from the scratch. Okay, so we already have that kind of APIs in the LangGraph. So it means we can create a graph and add the nodes, connect to the nodes, notify or extract that data programmatically using the LangGraph APIs. It will offer the flexibility to dev to connect to integrate to other systems. So it will be very easy to connect with the other systems. So if we'll see, we are as a developer, we'll just call the LangGraph APIs, and internal functionalities it will be take care how it needs to implement the nodes, how it needs to be implemented, that tools, it will take care of all these things. We need to just use the LangGraph API. Then we'll have a one workflow where we'll decide which components we need it, what will be the flow for our system, we need to decide it over here. Okay, then LangSmith. So LangSmith, we are using it for the debugging, monitoring, or tracing the code, or if we want to evaluate performance of the LangChain application or ecosystem, we can use the LangSmith. So it will help us to understand what happens inside the workflow, or where our workflow is broken. If we are getting any errors, where it got broken, right? So we can log all the information, or we can monitor that data. So in the LangGraph, we'll have LangSmith, which will log, trace, or debug our code, and it will evaluate what is the exact issue over here. So this is helping us to make the debugging easier. So suppose if our AI is generated incorrect answers, using LangSmith, we can inspect which node executed, which prompt was sent, which document were retrieved, which tool was called, and why the final response was generated. Okay, and where it got stuck, everything we can debug here and we can check. Okay, so today we build a strong theoretical foundation of LangGraph by understanding its core components. In the next lecture, we'll move to how they work together to create an intelligent AI workflows. So until next lecture, keep learning, keep building, and keep growing. I'll see you in the next lecture. Thank you.